Hi, this is section 4.5, properties of logarithms. So we have three properties for logarithms. The first one says that if you have a log with a product, you can expand that by separating the bases into two separate bases and having an addition sign between them. If you're dividing, you separate them with a subtraction. And if you have a power, you can move the exponent to the front, which we've been doing we started doing in the previous section. So let's apply these three laws. The first one says write the expression as a single logarithm. So notice we have two logarithms, but we only want a single one. So we can combine these into one if we use the first property because of the addition. The addition will tell us that we need to multiply the x times the y together. So 5 times x cubed is going to be log base 2. The base stays the same. And now we just multiply the arguments. 5x cubed. That is our final answer. So we combine 2 into 1. Same thing. Now we have 3. We need to combine those into 1. So I recommend that you just work with the first two and then you work your way out. So the first two, because of the addition, that means we're multiplying the 2 and the 10 together. So that's going to become log base 4 of 20 minus log base 4 of 5. The subtraction tells us that we need to divide the x and the y. So in this case, we got 20 divided by 5. So our final answer is log base 4 of 20 divided by 5, which simplifies to 4. All right, that's your answer. You could simplify further if you want. As you can see, this is really exponent 1. Because the bases are the same, the answer is the exponent, which is 1. So you could go the extra step if you want. I'll just leave it as that for now, though. For the next one, same thing, but notice that we have coefficients. Whenever you have coefficients, you want to apply rule 3 or law 3, and you want to move the coefficient to be in the exponent. So we're going to do that first. The 2 goes as an exponent, so does the 3 and the 1/3, so we have log base 10 of a squared plus log base 10 of b cubed minus log base 10 of c to the 1/3. All right, so let's combine the first two logs first. Because of the addition sign, that means we're multiplying these two. So we end up with log base 10 of a squared times b cubed minus log base 10 of c to the 1/3. Another way to write 1/3 is to write it as a radical, cube root. 1/3 exponent means cube root. And now subtraction means we divide. So our final answer is going to be a single logarithm, base 10, with a squared b cubed divided by cube root of c. And that is our final answer. All right, now we're doing the opposite. We're going to expand, as you can see. So there's a single logarithm, but we want to expand it out as much as possible. Notice there's a base 5, there's a base x, and there's a base 4. That tells you that you're going to have a total of 3 logarithms because there's 3 bases. So let's separate the numerator from the denominator first. And the way you do that, because of division means we separate those two by subtraction. All right, the last thing we can do is separate these two. And because this is multiplication, we expand it with addition. So the 5 plus the x. So there it is. The 5x became 5x separated with an addition, and we just brought that one down. So that's called expanding. All right, the next example, we're going to do something similar, but first we got to change the square root to be a rational exponent. Rational exponent is 1/2. The way you convert a radical to a rational exponent is you look at the index. The index is 2. That's your denominator. So now we can move the 1/2 to the front using log 3. And finally, we can expand the 7 and the x by addition. Log base b of 7 plus log base b of x. And I'm using parentheses because of the 1/2 coefficient applies to both of the logarithms. So you can either choose to distribute if you like and have them written in the front as coefficients, or you can leave it factored as the way I have it. I'm going to leave it factored. I prefer it factored personally, but either way is fine. All right, the last of these type is you're going to separate the numerator from the denominator by subtraction. And you may be tempted to separate these two, the x and the 3, but recall that log base 6 of x plus 3 does not equal log base 6 of x plus log base 6 of 3. That is not correct. The only way you can expand by addition is when you have a product, multiplication, not addition. So this would not be correct if I were to take that step. So we are done here. That's as far as we can go. Well, actually, there is one more thing we can do. I just noticed the exponent, you can write that in the front. So when you're expanding, you want to move the exponents to the front. So it's 2 log base 6 of x minus log base 6 of x plus 3 is our final answer. All right, for the next examples, we first need to combine these two into one single one before we can solve. So notice there's a subtraction. That means we're going to divide 24 and 3. So on the left side, the left side stays the same. The right side, if we divide, 24 divided by 3 is 8. Now we can use the 1-to-1 property because you have a log equal to a log. Whenever you have a log equal to a log, you can set the arguments equal to each other. So here are the arguments. You set those equal to each other. And now you solve for x. X equals 11/2. Fractions are fine. You could convert that to a decimal if you prefer. I personally prefer fractions, but either one is fine. All right, in this case, the only thing we can really do is combine these two logarithms into a single one by multiplication because of the addition. That tells us we must multiply the two arguments. So on the left side, we're going to have log base 2 of x times x plus 7 equals 3. So I'm multiplying the two arguments together, which means I should distribute. All right, if we rewrite this in exponential form using the definition, we're going to get base 2 to the third power is equal to x squared plus 7x. Now we subtract 2 to the third is 8, so if we subtract 8 to both sides to make this a quadratic equation, we have to set it equal to x. That's why I subtracted 8. Now we can factor this. We can factor this into x plus 8x minus 1, and therefore the two solutions are -8 and +1 if you solve these two factors. However, remember, you can never take the log of a negative number. So if you try to substitute -8 back into the original equation, you're going to have the log of a negative number. That is not possible. So this one is not a true solution. 1, if you plug in 1 here, you get a positive number. If you plug in 1 here, you get also a positive number. So our only solution is x equals 1. All right, for the next problem, it's very similar. We need to combine these two logarithms by multiplying the two arguments because of the addition sign. So if we do that, we're going to get log base 3. On the side, I'm going to go ahead and do the product of the two arguments. If you multiply those out, you're going to get x squared minus 6x plus 8. So I'm just going to write that here equals to 2. Now we can use our definition to rewrite this as an exponential equation. So our base is 3, our exponent is 2, and that's equal to the argument. So we subtract 9 from both sides. We're going to have 0 equals x squared minus 6x minus 1. Unfortunately, this is not a factorable quadratic expression or equation. We cannot factor it. So in the cases where you can't factor, you need to resort to the quadratic formula, which is here. So if you substitute all values, you should get 6 plus minus negative 6 squared minus 4ac all over 2a. And I'm getting 6 plus or minus, I think I'm getting 36 plus 4, which is 40 over 2. The square root of 40 is, let's see, that's gonna be 2 radical 10 if you simplify that. And notice that you can factor out a common factor of 2 for the numerator. So I factored out a 2 from the numerator in order to cancel the denominator out. So you would have to do that in order to simplify. So our final answer is going to be 3 plus radical 10 and 3 minus radical 10. But this is a negative number. If you type this into your calculator, you're going to get a negative number. And if you plug in a negative number here and here, you're going to be taking the log of a negative number. So this one is out. This is a positive number. If you type that into your calculator, you will get a positive number. And a positive number will definitely make this a positive and this a positive as well. So once again, we only have one solution. X equals to 3 plus radical 10. And that is the end of the section.